Okay, so we'll cover a couple of other theorems for the proportionality theorems. I would say, besides trying to memorize the theorem in terms of the words, if you set up a diagram, then the diagram really gives you the proportions for the proportionality theorems. For example, on the three parallel lines theorem, the three parallel lines theorem states if you have three parallel lines, like I have here, I'm going to label those lines A, B, and C. Those are my three parallel lines. You can tell by the tick marks here. But if they intersect two transversals, then they divide the transversals proportionally. So what I mean by that is if I let this length right here, I'm going to let this be x, this length right here be y, this z, and then this is q. The proportion, really, it's kind of set up for you already. You just need to make the ratios or fractions and then the equal sign. So x over y would equal z over q. Or kind of like another theorem that we went over. I could also set up something like z over x is equal to q over y. Those are equivalent proportions because x times q is equal to y times z. Z times y is equal to x times q, same thing. And then there's the three parallel lines theorem written out. So you should take a couple minutes to write that down in your notes as well before we go over the last theorem in 8.4. And then the last theorem for 8.4 is the triangle angle bisector theorem. So I have an angle bisector here. Let me label that point D. AD is the angle bisector of angle A or angle BAC. And that's the angle bisector. So it divides each of the lengths of the other two sides and then BC proportionally. Kind of like what we've done with each of the other examples. I'm going to let length AB just be X, length AC be Y. This is P for BD, and this is Q. So then AD, that ray, that's the angle bisector, divides these two sides, AB and AC, proportionally with BD and DC, or the way that I set it up, X over Y is equal to P over Q would be a correct proportion. And here is the triangle angle bisector theorem written out in words. You have a ray that bisects an angle of a triangle. So ray AD bisects angle BAC. It divides the opposite side into segments. What I called P and Q, those are the segments. Those are in proportion with the lengths of the other two sides, BA and CA, even though I just use single variables to represent those side lengths.